Hello everyone, welcome to my channel The Physics Web. In this special video, we will discuss the most important questions on relativity. These questions are not only fundamental to understand the concept of relativity, but they have also frequently appeared in various exams and discussions. So let us dive in and explore these key questions together. Question number 1. A relativistic particle of rest mass m0 is moving with a speed v. The value of v at which its kinetic energy is equal to its rest mass energy. Okay. So, kinetic energy of the particle is given and that is equals to its rest mass energy. Okay, rest mass energy is m0 c square. Now here we have to find the speed of the particle. Okay, and you can easily calculate the speed of the particle here if you know the relation between the kinetic energy, total energy, and rest mass energy of the particle, and that is given by K. Kinetic energy equals to total energy minus rest mass energy of the particle, m naught c square. Okay, so this is very much important. You should remember this relation. Okay, so total energy E is given by mc square. And in relativity, we know m is expressed as m naught divided by 1 minus v square by c square into c square. M naught is the rest mass, and this m represents the mass of the particle when it is moving with a relativistic speed v. Okay, so here we can write kinetic energy equals to m naught c square divided by square root under 1 minus v square by c square minus m naught c square. So as it is given that kinetic energy is equals to its rest mass energy, we can write here m naught c square equals to m naught c square divided by square root under 1 minus v square by c square minus m naught c square. Now, by taking this term to left hand side, you can write 2 m naught c square equals to m naught c square divided by square root under 1 minus v square by c square. So from here, square root under 1 minus v square by c square equals to 1 by 2. So from here, 1 minus v square by c square equals to 1 by 4. So now, v square by c square equals to 1 minus 1 by 4, that is 3 by 4. Okay, so v equals to square root under 3 by 2 c. Okay, so you can check c is your correct option. Okay, so this relation you have to remember, very much important. Okay, k equals to e minus m naught c square. Next, question number 2. The kinetic energy of a particle of rest mass m naught is equal to its rest mass energy. Its momentum in units of m naught c, where c is the speed of light in vacuum h. Okay, so in the first question, we calculate the speed of the particle. Here we have to find the momentum in terms of m naught c. So there we have to find the value of that constant. Okay, so p momentum. Again, here also it is given that kinetic energy of the particle is equal to its rest mass energy, that is m naught c square. Okay. And if you calculate the total energy here, that is, so from this relation, k equals to total energy minus m naught c square, m naught c square. So total energy will be k plus m naught c square, k is m naught c square. So total energy will be 2 m naught c square. Okay. So here, similarly, you can remember a relation between the momentum and kinetic energy of the particle. So using that relation, you can directly find out the momentum. Here we'll solve this question in two ways. Okay, so first let me write down that formula from where you can directly find the value of the momentum. That is momentum P equals to 1 by C square root under K times K plus 2 m naught C square. Okay, so you should remember this mathematical expression. This is the relation between momentum and kinetic energy of the particle. Okay, so here you can directly use the given value of the kinetic energy. So momentum of the particle P equals to 1 by C square root under Kinetic energy is your rest mass energy that is given. So m naught c square plus k plus 2 m naught c square. So that is 3 m naught c square. So momentum equals to 1 by c. So this will be root 3 m naught c square. So c will cancel out. So momentum P equals to root 3 m naught c. So momentum is root 3 times m naught c. Okay. So root 3 and value of root 3 you know that is 1.732. Okay. So here answer will be 1.73. Okay. So let us solve this question in second way. Okay. So from that from our first relation we find that energy equals to 2 m naught c square. Now you can use this relation E equals to P square c square plus m naught square c4. Okay, so from here P square c square equals to, sorry, this is E square. Okay, so this is E square. E square minus m naught square c4. So E is 2 m naught c square. So E square will be 4 m naught square c4 minus m naught square c4. So P square c square equals to 3 m naught square c4. So from here PC equals to square root under 3 m naught c square, or P momentum equals to root 3 times m naught c. Okay, so from in this way also you can check that momentum is root 3 times m naught c. So root 3 is 1.72. Actually, I will suggest you should remember some constant value like root 2 equals to 1.414, root 3 equals to 1.732, root 5 equals to 2.236. Okay, actually, in this relativistic case, in many questions, you have to use this value of this constant. Okay, so try to remember this. So here is your answer is 1.732. Question number 3. A rod of proper length L0 oriented parallel to the x-axis moves with speed 2c by 3 along the x-axis in the S frame. Okay, so let me what they have given that there is a S frame. Okay, so let this is our x direction and this is S frame. Okay. So there is a rod whose proper length is L0 and this is moving with speed 2c by 3. 2c by 3 with respect to S frame. Then the observer is also moving along the x-axis with speed c by 2 with respect to the s frame. So there is an observer which is also moving in the x direction with speed c by 2 with respect to s frame. Okay. The length of the rod is measured by the observer. So length of the rod measured by the observer. Okay. So in this type of situation, remember, if you have to find speed of one object with respect to other, speed of an object with respect to an observer, with respect to a frame, when the information with respect to S frame is given. Like here, we have to find the length of a object with respect to another object or another observer or another frame. So in this type of question, try to consider one to be S dash. Okay, so like here, this for this observer I am considering this to be s dash frame. Okay, so you can use our general relation, like we know if s dash frame is moving with speed v with respect to s frame and there is a particle like particle p, so we can define like vx dash, vy dash, vz dash, all the velocity transformation formula, length time dilation formula using this concept. So try to consider this type of situation. Okay, so here you can see if we consider this to be s dash frame, so I can write speed of this observer v equals to c by 2 and speed of this rod. Okay, so I am writing it to be Vx because it is given with respect to S. So this is 2c by 3. Okay, now here we have to find the length of the rod with respect to S dash frame. Okay, so we know that length of a rod get contracted when this rod has a velocity component parallel to its length with respect to the observer. With respect to the observer. Okay, so if we have to find the length of the rod here, so we have to find the speed of this rod with respect to this observer. Okay, so I am defining that term to be Vx dash. Okay, so Vx dash is the speed of this rod with respect to observer O. Okay, so Vx dash. Next, so proper length is L naught, V is C by 2, and there is one more, Vx is 2C by 3, Vx dash. And here, in this case, length of the rod with respect to S dash frame will be proper length into square root under 1 minus V square by C square. Here, this V represents speed or velocity of the rod with respect to S dash frame. Okay, so we have to find this V. V means this Vx dash. Okay, length, speed of the rod with respect to S dash frame. Okay, so Vx dash. So we know this can be written as Vx minus V 1 minus V Vx by C square. Vx V are given, so you can check here. Vx Vx is 2C by 3 and V is C by 2. So 2C by 3, this is C by 2. So 1 minus 2C by 3 into C by 2. So C square will cancel out. This will be 1 by 3. So this is C common 2 by 3 minus 1 by 2. This is 2 by 3. So this is C 6 4 minus 3 2 by 3. So C times 1 by 6 into 3 by 2. So this is C by 4. So here you can see speed of this rod with respect to O is C by 4. So Vx dash is C by 4. So here you can see the velocity component is along the x direction and the rod is oriented along x direction. So this is parallel component of velocity component parallel to its length. Okay, so here in this case we can use this formula, or in place of this V we can use this value. Okay, so now L naught 1 minus V C by 4. So it is 1 by 16. C square will cancel out. So L naught root 15 by 4. Okay, so C is your correct answer. Question number 4. A pion moving with speed 0.4 c emits muon in the same direction. Speed of muon in the rest frame of pion is 0.2 c. Calculate the speed of muon in lap. Okay, so here, as we discussed in the question number 3, same situation, you can take this lap frame to be S frame. Okay, and pion frame to be, so there is one particle pion. Okay, another is muon. So pion emits a muon. So you have to find the speed of the muon in lap frame. Okay, so you can consider one to be S dash frame. So I am considering this pion to be S dash frame. Okay, so you can see, always compare the situation like to this S frame, S dash frame, S dash is, if S dash is moving with respect to S with speed V, then for a particle P, we can express this velocity component of the particle in S and S dash frame with a velocity transformation, that is Vx dash equals to Vx minus V1 minus V Vx by C square. Okay, so you will use this similar situation here. So pion is moving with speed 0.4 c. Okay, with respect to S frame, so you can write V equals to 0.4 c. Next, speed of muon in the rest frame of pion. So speed of muon, this is the particle with respect to P. That means Vx dash equals to 0.2 c. Now we have to find the speed of the muon in lap frame, that is with respect to S frame. So Vx we have to find. Okay, so Vx dash is given, we have to find Vx. So we have to use the inverse Lorentz transformation. Inverse. Okay, so that will be Vx equals to Vx dash plus V. 1 plus vx by c square. So vx dash is 0.2c plus v 0.4c, 1 plus 0.2 into 0.4. So c square will cancel out. So this is 0.6c by 1.008. Okay. So this will be equals to 0.55c. Okay. So A is your correct option. Question number 5. A person is going in car which is moving with respect to ground with speed 3c by 5, throws a ball in upward direction with speed c by 2. Okay, so you consider a person is going in a car. So this is moving with speed 3c by 5 with respect to ground. Okay, so consider here ground to be our S frame. Okay, so we can write V to be 3c by 5. Consider this to be S dash frame. Now this person is throwing a ball in upward direction with speed c by 2. Okay, so the given condition is that Vx dash is 0. There is no component of velocity in x direction and the y component is c by 2. This is given in s dash frame. Okay. Now what is the speed of the ball with respect to ground? Ground is our s frame. So to find the speed of the particle with respect to S frame or ground, we have to find the component of velocity in x direction and y direction, that is square root under vx square plus vy square. So we have to find basically vx and vy. Okay, vx and vy. So again here we have to use the inverse Lorentz transformation, and we know from velocity transformation and inverse Lorentz transformation, vx equals to vx dash plus v 1 plus v vx by c square. Vy will be vy times 1 minus v square by c square, 1 plus v, sorry, this will be vx dash. Okay, vx dash by c square. Okay, let me first tell you the important part in this problem. Okay, why I am writing this relation, like for vx why I am writing this expression, and for vy why I am writing this. And you remember for vz here it will be vz into 1 minus v square by c square, 1 plus v vx dash by c square. Okay, so remember in this type of questions, like this is your s frame, this is your s dash frame. Okay, your s dash frame is moving in the x direction. Okay, this is x dash, this is x direction with speed v. Now there is a particle whose component of velocity in s dash frame is s in s frame is vx vy vz, in s dash frame vx dash vy dash and vz dash. Okay, so in this case if you calculate the velocity transformation, so vx dash will be vx minus v 1 minus v vx by c square, vy dash equals to vy into 1 minus v square by c square, 1 minus v vx by c square, vz dash equals to vz 1 minus v square by c square, 1 minus v vz by c square. Remember, you can use this relation only when this s dash frame is moving in the x direction with speed v. If the s dash frame is moving in this direction, that means in y direction, let this is our y direction with speed v with respect to s frame, then in that case the velocity transformation will be like this: vx dash equals to vx into 1 minus v square by c square divided by 1 minus v vy by c square. Vy dash will be vy minus v 1 minus v vy by c square, and vz will be vz vz dash will be 1 minus v square by c square, 1 minus v vy by c square. Remember, similarly, if s dash frame moves in z direction, then there will be change in the relation of this velocity transformation. Okay, so come back to our questions. So Here we have to find Vx and Vy. Okay, so using this relation, we can find Vx and Vy. So Vx, okay, so Vx here, Vx dash is 0. So 0 plus V is 3c by 5. Okay, V is 3c by 5. And Vx dash 0. So 1 plus 0 will be 0. Now Vy, okay, this is Vy dash. Okay, so this will be Vy dash is your c by 2 square root under 1 minus v square by c square. So v is 3c by 5. So it will be 1 minus 9 by 25. So 25 minus 9, 16 by 25. So this will be c by 2 into 4 by 5. So this will be 2c by 5. Okay, so Vx is 3c by 5. Vy is 2c by 5. So Vx 3c by 5. That means 9 by 25 plus Vy 4 by 25 c square. Okay, so 9 plus 4, that is your square root under 13 by 5 into c. So D is your correct option. Question number 6. Proper mean lifetime of a unstable radioactive particle moving in lab frame is 2 microseconds and it is found to travel a distance of 600 meter. Speed of the particle is. Okay, so proper mean lifetime. So let this to be T naught, that is 2 microsecond. Okay. Now distance travel by the particle with respect to lab frame. Okay. So this distance with respect to lab frame and that is 600 meter. Okay. So you have to find the speed of the particle with respect to lab frame. We can define like speed of the particle with respect to lab frame equals to distance traveled by particle in lab frame divided by time or lifetime of the particle in lab frame. So from here we can write that speed v equals to distance. Okay, so this is your 600, okay, meter divided by t. This is the time or mean lifetime of the particle with respect to lab frame, but its proper time is t naught. So using the relativistic effect, we can write the time or lifetime of the particle in lab frame equals to T naught divided by 1 minus v square by c square. V is the speed of the particle in lab frame. Okay, so this is your T naught, that is 2 microsecond. Okay, so I am writing this to be minus 6. Okay, so let me first write the mathematical expression only. Okay, so that is your d by T naught. So this will be 1 minus v square by c square. Okay, so we can write this relation as square root under 1 minus v square by c square. Okay, v equals to v into t naught by t. Okay, if we divide and multiply c here, then this will be v by c. So t naught is 2 microseconds. So this is 2 into 10 to the power minus 6. Distance 600 meters. So 600 c. Value of c is 3 into 10 to the power 8. Okay, so 2, 3, 6 cancel. So here is 10 to the 2. So it will be 10 to the minus 8, 10 to the minus 8 and 10 to the 8. So that will cancel out. Okay. So from here, square root under 1 minus v square by c square equals to v by c. Okay. So this will be 1 minus v square by c square equals to v square by c square. Okay. So this is 2v square by c square equals to 1. So from here v equals to c by root. Okay. So we know, as we have discussed, root 2 equals to 1.414. So this will be around 0.7 c. Okay. So you can check. So B is your correct answer. So for today, let's stop here. Thank you for watching this video on the physics web. We hope this deep discussion into the most important questions on relativity has been helpful. If you found this video useful, please give it a thumbs up and share it with your friends. Don't forget to subscribe to the physics web for more insightful videos on physics topics. Hit the bell icon so you never miss an update. Feel free to leave any question or comments below and let us know which topics you would like us to cover next. Let's continue exploring the wonders of physics together. Until next time, keep questioning, keep exploring, and keep learning. Thank you.